Today we'll be looking at Module 4, Lesson 10, and our aim for today is Kipsters will be able to expand and simplify multiplication expressions. Expand and simplify multiplication expressions. So I'm going to actually begin by looking at the do now. I asked you whether these were true statements or not. And what we should have said is, yes, they are true. And the reason for that is we know no matter what order we multiply in, we still get the same answer. For example, down here, I know 13 times 2 is 26. And I know 26 times 4 is 104. Guess what? Kind of the same idea over here. If I do 2 times 13, still 26. 26 times 4, that's still 104. Up here, I can actually switch these around, and I can say this is 21m equals, same thing, 21m. So it doesn't matter what order we multiply in, we still get the same answer. So we can move things around all we want. But we're going to look at a few different ways to multiply today. We're going to talk about the regular x that we're used to, the dot for multiplication that we know, the adjacent form of multiplication, and parentheses. First of all, let's start with the regular x. So for example, we know that 5 times 2 is an example of what this looks like. But when we only have numbers, yes, this works. If we have variables, no, this doesn't work, because then we've already talked about this a couple times. If I use that x when I have variables present, I might think it's an actual variable. So that's why normally this is the best one we choose. This is one of our favorites in algebra, the dot. Of course, it could look like this. It could be 5 times 2. Of course, in variable form, we might have x times a, something like that. So with numbers, yes, we can use this. And with variables, yes, we can use it. The dot makes sense in a lot of situations. Adjacent. The word adjacent, oh my gosh, such a fancy word. All it means is next to. Oh, that's all it means. So if your brother's room is next to yours, you would say your room is adjacent to your brother's room. So here I can do it like this. Adjacent multiplication looks like this. 2a. That means 2 times a, always. Doesn't mean addition. Always, always, always means multiplication. So with numbers, this doesn't really work, because otherwise I'd look at this and I'd think, well, is it 52 or is it 5 times 2? With numbers, we don't use adjacent multiplication. But with variables, heck yes we do. I can say things like 3y or 12m squared, in which case this means 3 times y, this means 12 times m squared. And then our final form of multiplication we know is parentheses multiplication. So here's what I mean by that. I can do 2 times 5. So that's what that means. When I have it in parentheses, this means 2 times 5. Or I could even do it like this. X parentheses 3. This means x times 3. So with numbers, yep, we can do it with numbers. Makes sense. Got the parentheses there to show where our numbers are separated. With variables, it makes sense as well. I could even have only variables. For example, I could say a times b, or I could say a times c. I could do anything with the alphabet there, and I would still get what I need to get there. Cool. All right, let's go ahead and flip the page and see if we can keep going with this concept of multiplication in all kinds of different ways. First, let's talk about what we name some of these items. If we take a look here, I've got a big, long expression written. We call each of these little chunks terms. These are called terms. And a term is just a combination of variables and numbers in multiplication. So here, this chunk is called a term. That chunk is called a term. 8H3, 7G, those are all called terms. Then we have this thing called right here, this is the 7 and the 8 are what we call coefficients. Coefficients. And a coefficient, that's simply the number or the factor, the number or factor of usually a variable. Of usually a variable. So for example, I can say 7 is a coefficient. 8 is a coefficient of H. 7 is a coefficient of G. So let's actually put some of this to use. I want to write these with the fewest symbols as possible. So on this one, I can see 6 times b. Now, this isn't a very good way to write this expression. I would actually recommend, if someone were to write this, 6 times b like that. Otherwise, you might think that's a variable. So here, if I want to simplify it, I can simplify it as far down as I can as 6b. This is adjacent multiplication. My coefficient is 6. That's the number multiplying my variable. My variable is b, so again, my term, my product, my whole chunk of stuff is 6b. Let's take a look at this one. So I know 4 times 3 times h. Well, the simplified expression, 4 times 3 is 12. 12 times h, I can write that simply as 12h. What's my coefficient? See if you can write it down. Should be 12. Obviously, my variable is h. My whole term, the product I'm talking about, is the product 12h. So what I encourage you to do is I'd encourage you to try these next 3 without me, and then come back and see if you got some of them right. Okay, so be careful on this first one. 2 times 2 is 4. And 4 times 2 is 8. So make sure you don't have 6 here, just like with our exponents. So I can say 8 times a times b. But of course, we can use adjacent multiplication to make that even smaller. I can say 8ab. Here, my coefficient is 8, just the number multiplying the variables. And then a and b are my variables and my other factors. So my whole term, my whole chunk of stuff I'm talking about are 8ab. Next one, I've changed the x to the dot so it's not as confusing. But now I need to think here, what can I pull together? Well, I can rearrange things, right? I can say 5 times 3 times m times p. 5 times 3 is 15. And then I can just do adjacent multiplication, and I can do m and p. Easy enough. We know we can multiply in whatever order we want. That's why I flipped the 5 and 3 next to each other so I can multiply them. So here my coefficient is 15. My other factors, my variables, are m and the letter p, and of course my whole chunk of stuff. My whole term is 15m p. Last one, 1 times g times w. Some of you might have said, oh, it's 1gw. Guess what though? Anything that I have times 1 is always itself. If this were 1 times 5, you would know it's 5. So I can actually say here, this is just gw. That's the best one I can say. And when I do that, I know, even if there's not a number here, I know 1 is always the coefficient. So here, 1 is my coefficient. GW are also my variables. My whole term is GW. Again, when we don't see anything out front, we just assume it's a 1. All right, last one. See if you can get this simplified as down far as you can. Label the terms, the coefficient, and the variable. So again, pause the video, try to simplify this down as far as you can. Okay, I'm going to go into this. I'm going to rearrange things. I can multiply in whatever order I want. We talked about that earlier in the unit. So I'm going to do this. I'm going to say, well, 4 times 5 is 20. But then I just like to have my letters in alphabetical order. So I'm actually going to say times A times M times X. So I can say this whole thing simplified all the way down is just 20AMX. So here, my whole term, my whole chunk of stuff I'm talking about is 20AMX. My coefficient is 20. My variables are A, M, and X. I don't know what they're equal to yet. All right, continuing right along. So what I'd like you to do is, I again want you to try to pause the video, and you can see that we have some terms here written. I want you to see if you can expand them out as far as you can. Let's take a look at just one example right here. On 12g, I know I can say that this is equal to 6 times 2 times g, but I can break it down even further. I know 6 is equal to 3 times 2, but then I still have this other times 2, right? So times 2 times g. Your goal is to expand each of these terms as much as you can. So pause the video, come back in about 2 minutes, and see if you expanded the expression well enough. All right, hopefully you've paused and shown integrity. Let's see what we've got here. So I know this is 6 times g. But I want to think, well, what can I break 6 down into further? I know 6 I can break down into 3 times 2 times g, and that's all the further we go. Anything else would just be times 1, and times 1 doesn't really do anything. Next one, 7's a prime number, so I can't break 7 down any further. So I'm going to leave it as 7 times a times b times c. The only other thing I could do would be times 1, but I don't need to do that. I don't need to know 7 times 1 is 7. 1's kind of an unimportant factor. All right, next one, 24. You might have done this one a couple different ways. 24 is kind of a unique number. I like to think of 24 as 6 times 4. And then I also have times h and times x. But I need to think about 6. Well, I've already broken 6 down earlier, so look back and see what you can break it down into. Looks like I've already broken it down into 3 times 2. But then 4 can be broken down as well. What multiplication problem can I think of 4 as? I can think of it as 2 times 2. And so then I just have to add on h and x, and I am good to go. All right, last one. We've already said 7 doesn't really work out here. But I can get 9 down. I can get 9 down a little further. So I'm going to write 9 as 3 times 3. So I can do 7 times 3 times 3 times g times h. So we're all set up for success here. Hopefully you've paused the videos and you're reaching about the 15-minute mark. And we'll go ahead and go on with university style class in just a second.